Welcome to this video series for IT students or Information Technology grade 12 students who are revising for their practical exam or paper 1. And this is the 2023, not the November, but the June supplementary paper. We are looking at question 3, which is the OOP question. Reminder, there are links in the video description to the data files, which you can download to try it out yourself. There are also links to jump to particular questions, as well as links to the other questions of this exam paper. You can go check out those videos as well. So let's get stuck into some OOP questions. So here we've got an object which deals with smart switches that have been installed in the monitor and automotive home devices and determine if they're on or off. So we've got an incomplete object class, which is called smart switch underscore U. And so there's two files that we need to work in, and that's the key. Make sure that you're using two files. So the first one, this is where we're going to work first. 3.1 will probably work with that one, and 3.2 will work in the main unit. So this is our graphical user interface. We will probably only work with this in question 3.2. We first need to set up our object, and then we'll come here and use the object in the main program. So let's scroll down. There's 3.1. We've got an incomplete class for a T smart switch, and we've already got 4 attributes that describe it. Code for the method called determine switch status has already been given, is already incomplete, but given to us. So there are the attributes. We've got an ID, which is a string. We've got a device, which is the string, which is the name of the device. We've got the power usage, the amount of energy, power in watts, and the switch status, which is a true or false Boolean value. We don't need to add any other attributes because you can use those ones. So let's start with 3.1.1. Write code for the constructor method that will receive a switch ID, the device name, which is that, and the power usage of the switch as parameters. You notice it doesn't say anything about the switch status. Assign these values to the fields, and we must by default set the switch status to false. So when we go to the program, please take note that this is just the main program. You need to do all of 3.1 in the object. So you need to come over here. You see, there's my object class. We need to double click on that to get to the code. This is where 3.1.1 and 3.1.2 and so on goes. Only 3.1's questions go here. So there are our fields. We want to create a constructor. So over here, we're going to write down a constructor. Let's write underneath the provided one. So constructor, because it is a constructor, and we're going to call it create because that's the name we always give it. And we want to give it 3 values. We want to give it the ID, the name, and the power usage, which we know are going to be string, integer. So we're going to give it the switch ID, which is going to be of type string, semicolon, and then we're going to give it the device name, which is also going to be of type string, and then we're going to give it power usage, which I'll make of type integer. You could have actually just taken that out and just had a comma, so you had that, comma, that of type string, but that's fine as well. So those are my 3 parameters that are coming into the create constructor. Control Shift C, and here's where we got the code. So remember, we're going to take those values and assign them to the field. So we put the field name first. That's why there's an F in front. Well, it's not why there's an F, but just remember, F first, we have the field name, and we're going to give it the value from the parameter. So that value is going to be put into F switch ID. Then F device is going to get its value from SD name. The parameter is going into the field, and then F power usage is going to be assigned the value of our power. Then they said by default the F switch status is going to be set to false. That's a Boolean, so we just type it in like that. So that is our constructor. 3.1.2, write code for an accessor method called getSwitchID to return the switch ID. So this is an accessor method, meaning if we are in another unit, we want to access the switch ID. In other words, we're going to send back the switch ID. We're returning a value, which means it's a function. It's a get method. So let's come up here. We are returning a value, so we can say function get switch ID, and it's returning the ID, which is a string. So we're going to return a string value. Control Shift C, and we are simply saying result is equal to the field switch ID. And that's literally what an accessor method is. It's a function that doesn't take any parameters normally. It just returns a value, and the result equals that. 3.1.3, write code for the method called energy used that receives a number of hours as an integer. So that's a parameter that the device was switched on. So that's going to be the value in brackets. And we're going to use this formula to calculate and return. So that means we are making this a function that's going to return the amount of energy used by the device. if you see this calculation, the number of hours is going to come from the parameter. The power usage we've got as a field there, and we're going to calculate that and return the value, which looks like it'll probably be a real value. If you look, we divide in. So let's go do that. So at the top here, we know that we're returning something. So it's a function. We know that it's called energy used, and it takes in a value for the number of hours. I'm assuming number of hours will be an integer. You can always change it to a real later if we need to. And we are sending back a calculation, which is probably going to be a real. Control-Shift-C. So our calculation is, we can say result equals, we're sending back a calculation, which is the power usage, which we can get from our power usage field. And we are then going to multiply that by the hours. Where do we get hours from? We get it from the parameter. Multiply that from the hours, and then we're dividing that by 1,000. So we divide that by 1,000. But so there we go. That should work. BODMAS does work to do this first, so it should still work. If you're not 100% confident, you can always put your brackets there just to make you feel better. But BODMAS would have made it work properly. 3.1.4, write code for a mutator method called setSwitchStatus, which can be used to switch the device on or off. The method must receive a Boolean value as a parameter and set the switch status to the received value. So we are going to get a Boolean value, and then we're going to put that value into the switch status attribute. So this is actually a mutator method technically. Oh, they said that, yeah, that's a mutator method. Mutator method means it's a procedure. We're not returning anything. We are simply going to call it set switch status, and it's going to take in a parameter, in this case a Boolean value. So I'm going to call this B status of type thin ghost. I mean Boolean, because it's a Boolean, because it's a thin ghost. Control-Shift-C, and all we are doing is changing the switch status variable to the new parameter that we've got. So take that value and put it into the switch status. That's literally what it's doing. 3.1.5, write code for the toString method to return a string with all the attributes in this format. So I'm going to copy this because I've got it in digital format. And they give us a hint that we must determine switch status to determine if the switch is on or off. If we look at this method, determine switch status, we're going to press Control and just jump to it. You can see it will return an on or off for whatever the switch status is. So we don't need to figure out if it's true or false. This will return the text on or off. So let's go make a function, because toStrings are always functions that return a string value. Control-Shift-C, and here we want to create, I'm going to normally create a variable called sline, and we compile our string. We know it must look something like this. So my sline needs to look like this. So we take the first line, I'm just going to copy and paste it there. We want the text switch ID. They don't say anything about a tab. What I'm actually going to do is I'm going to look ahead to see what it looks like when we display the results. And that's what it's going to look like. So there's no tabs or anything like that. So that's fine. So let's make it like that. So we want to get the switch ID. So we're going to then add the field switch ID, which is a string. So that's fine. And then to make a new line, we're going to add a #13. That's what sline is going to start off with. Then I'm going to take sline is equal to whatever's sline plus, let's add on to it. We're going to add in device. So we're going to add the text device, and then we're going to add the device name, which is f device. And then we're going to add a #13 because we've got a new line. And we could technically just copy this and paste it again. And we take whatever's in sline, which is those first two lines, and we're going to add the word power usage. And we want the word power usage. So we're going to use our field for the power usage, and then don't forget we want to add that W for the watts at the end. So I'll put a space W at the end. Now the problem with power usage is we know that is a integer value, so we need to convert it. So we need to convert this from what it is, int, to a string, so that we can put it into the toString. And then we need to add one more line, which is going to be switch status. And then we're going to add whatever we get from the determine switch status value, which returns a string. So I can literally just come here and just call the determine switch status. It will return on or off for that status. So I think that is correct. I look over there. There we go. Let's look, scroll down. There we go. I think it'll look like that. So I'm happy with that. So that's my toString function. So there we go. We can now move on to 3.2. Make sure that you save before you make any changes. We can run it now to see if we've got any syntax errors, but we can't actually test these methods because we haven't used them yet. So it compiled, which means our syntax is correct, when we run the program using them in the question 3.2, then we'll determine if they work and we might have to come back and edit them. But just remember, all of these methods would be created because we need to use them. They'll never ask you to create a method you're not going to use. We've technically used the determine switch status already, so we've already ticked that one off. Doesn't mean we can't use it again. We might have to, but we need to make sure that we use all of these functions and procedures and constructors at least once. They will never ask you to create one and you don't use it. So make sure that you tick them off when you've done them on your question paper so that you know that you've used them. If you haven't used them at the end of the question, you've probably missed something out. So let's go to 3.2. So we've got the incomplete program, contains the code for an object class to be accessible and declares that object smart switch object variable. So let's go to 3.2.1. We've got a list box that contains the devices and their power usage in the format of that. So you can see there you've got the device usage and the power usage, and the switch ID is coming from a combo box. We want to write code that extracts the switch ID, extracts the name of the device and the power usage, and then uses that to instantiate our object. And then we're going to call the toString to display its values in the rich edit. So quite simple. Let's go click over here. We're going to get that value, get those two values, and then instantiate our object. Now, if I scroll to the top here, you'll see that that is the object that we're going to work with. So over here, 3.2.1, let's first get the values. We want to get the switch ID, which is a string. So I'm going to call this SRD because that's my switch ID, which is going to be a type string. And then I'm also going to make an SLine, which is going to get the value from the list box. And we need the name and the power usage. So we need a device name. So let's call it sname, and we need the power usage, which will be an integer. Power of type integer, and let's go and extract that. So let's do the first little bits here first. So let's first get the ID. SRD is equal to whatever's in the combo box, which is CMB321 combo box. How do we get the value? It's the text property. Then I need to get the value from the list box. Now, how do I get the value from the list box? So we're looking at the list box 321. We are going to get dot items, and then in square bracket we need to put the position of the item that is selected, which is the list box's item index. Don't just put item index, you must say the list box dot item, not height, but item index, and that will go, that's the one that's selected. Go fetch the item at that position and put that value into SLine. So SLine is going to look something like this, fan hash 100. So SLine will look something like that. So now that we know that it looks like that, we want to get the name. So sname is going to be copying from SLine starting at 1 until the position of the fan -1. So we're going to find the position starting at 1 until the position of the hash -1. So we need to find out where that hash is. So we're going to find the position of the hash because we don't know where that hash, it might not always be at position 4, depends on what is the item that we select. So we want to find the hash in SLine, but we don't want to copy from 1 till the hash because we don't want the hash. We want 1 before the hash. So we say the position of the hash -1, and that'll get the sname. Then to get the 100, we into our power, because there are only two things, I can technically copy from SLine starting at the position of the hash in SLine. So we're going to start at the position of the hash. No, we don't. We want to start 1 after the position. So find the position of the hash +1, and we want to copy how many? Let's say like 10 values, because that's all that's left over. So hopefully it doesn't go more than 10. So whatever's left over after that, it will copy. Now the problem with this is copy returns a string. Our power is an integer, so we need to convert this from a string to an int. We didn't have to do that with the first one for name because name is already a string. But there we go. I think that is correct there. So that's extracted the ID, the name, the power. Now we can go our object, obj smart switch. Now people make this mistake. They say .create because we think it's a method that we use like that, and it looks like it's fine. That's not how you use the constructor. You always say it's equal to what type of object it is. It's a T smart switch, so that's the type it is, .create. This is the only time that you do it like this. All the other methods, you say the object dot its method. Here you say the object is assigned the value of what type of object it is, .create. And we need the switch, which is, we've got our switch ID in that variable. We need the name, which is in our sname variable. And we need the power, which is also in our power variable. So that's going to create or breathe life into our object. And then in the rich edit, .lines, we're going to then call that object .toString. You can't just go .toString. You can't just say toString because you could have multiple objects that have toString functions or multiple tsmart switches. You need to say which one .toString. Like for example, when you use rich edit, you don't just say lines.add, you say which rich edit .lines.add. Let's go test it. Let's drag it here. Keep it at that switch ID, but we're going to select fan #100, go instantiate the object, and nothing happens. Why did nothing happen? So maybe there was something wrong with my toString function. Let's go back. Maybe we made a mistake. Mr. Long, I've got a funny feeling I know what my mistake was. Because when I did this S-line, look here, Mr. Long, you were so silly. S-line, we constructed our string, but we never returned the string. So we must come back here and say result is equal to S-line. So once we've done S-line and we've created it, we must send it back because it's a function. Do you see how you can only test it once you use it in the main program? So there we go. I think that's the mistake I made there. So let's go run it. Try it again. We try that one. Boom. There we go. That's much better. So there we go. Let's move on to 322. Use the radio group to select the switch to be on or off. The set switch status, so we can change it using the value selected from the radio group. So the value on represents true, the value off represents false. And then we display the status object in the rich edit. So we're just going to type in the name of the switch and then whether it's on or off. So what we're going to do, we're going to take note of on is the first option, off is the second option. So let's scroll down here and we're going to click on that button. So the first thing is we're going to see which option we're looking at. So how do I know which option of the radio group? So the radio groups .item index will tell us which one is selected. If it's a 0, we know that the first option is selected and that is the on option. So we know that it's on. If that's on, then we want to change our object and we're going to set the switch status to it's on. So that means we must set it to true. And if it's not a 0, that means it must be the other option. Then we're going to do the exact same thing, except for we are setting it to false. If you wanted to, you could have also put this part here, else, and if the index is a 1, then you do that. Okay, so that's resetting the switch based on what we've set. Then we need to display in the rich edit .lines.add. How are we displaying? We're displaying the name of the switch ID. Now we have a couple of methods here. So we can get the switch ID using that function, and we can get the switch status as an on or off because they want to display it as an on or off. So we can actually get that from there. So I think we're going to use these two methods. We're going to get the switch ID, get the status, and then display it like that with a colon in between. So the first thing we're going to display is the object dot get the switch ID, which is a string, so we're fine with that. Then I'm going to say plus, and I'll put on a new line. Then we're going to put a quote, colon, space, quote, and then we're going to add object dot determine switch status, which is also going to return a string, but that's fine. So that'll return the on or the off, and we do that. So go get the switch ID. Let's put this on a new line so you can see it there. Go get the switch ID, add a colon, hash, and then add the switch status after we've made the change. Let's go see that. Take note, this will not work because until we've instantiated our object. So we must first instantiate our object. Then we can see that it's off. If I select on, it's now on, but if I select off, okay, so there we go. And it used the switch ID that we are using. So 3.2.3, a text file called log keeps a record of the date, time, switch ID, and the status of the switch. Code has been provided in the form create to show the current time. So the current time will be displayed there. Write code to the following. We're going to open the log text file to add a line of text. So we are writing to the text file. We're going to add a line of text which contains the current system date, the current time, which we can get from the time, I'm assuming from the label, and then the switch ID with a hash and the switch status. So it must look something like that. So we're going to keep adding this to the text file. So we're going to add a line of text. We're not recreating the text file, we just add it onto it. The date function must be used to extract the current system's date. The formats of the date and time are dependent on the regional settings, which may differ, but we can get the time, I'm assuming, from that label. So it's just the date that we need to get, which is the current date. So if I open up, here's the log text file. I've opened it already, so we just want to keep adding on to it. So let's click on the right to the text file. So first of all, we need a text file variable. So let's call it my file of type text file. And I'm going to make an S line so that we can say what type of string we're going to add to it. So let's first construct the string that I want to add. So I'm going to say S line is equal to, we first want the current date. So that date, to get the current date, we can just type in date. Close bracket, open bracket. But that is of a date format. We want to convert it to a string. So I'm going to convert that from a date to string format. You could have also used now to get the current date, but that'll work there. And then we're going to add a comma and then the time. So where do we get, we're going to add a comma. That's easy, but where do we get the time? That's going to be from the LBL time label. So we're going to get the caption of that. So they told me that will be automatically updated. And then we're going to add another comma, and then we're going to add the switch ID. So we're going to add another comma. I don't think there's a space there. We can check in the logbook if we want. No, there doesn't look like there's a space after the comma. So after that, we're going to add, now how do I get? We're going to get the object, which is my smart switch. We're going to get the switch ID, because that's what we want to display next, the switch ID, and then we want to do the switch state, which is almost exactly to what we did previously, except for we got a hash now. So then after that, we're going to add a hash, and then we're going to add the object dot determine switch status. That'll be the on or the off. So that's the line that we want to display. So what I'm going to do, just to be sure, I'm going to show message S line, just so I can see what it looks like. So let's run it and see that we've constructed the correct line. So we're going to instantiate our object. I'm going to set it to on, just so we can see that that works. So we can see the current time. Let's write text file. It's not actually going to do it, but is that the format? We've got the date, which is today's date that I'm doing it, correct? That is the time, that is correct. We've got the switch ID and we've got the status. So that's, I think, exactly how we want it to look. So we've created S-line to be perfect, so I don't need to display it. We want to add it to the text file. So let's go assign file, and we're going to assign my file to the text file called log.txt. So log.txt. So that's going to connect my variable to the text file. So whatever we do to the variable will now happen to the text file. And we are writing to the text file. We're not getting rid of the text file. We just add it on. So we are appending the file. And then we're going to write line to the file. What are we writing? We're simply writing my S line that I've created. That's literally what it is. And then once we're done, we can say close file. Just remember, with write line, you just don't write line S line. You write line to the text file what you are writing. So I think that's it. Let's run it. We're going to instantiate this object. I'm going to set the switch off, and let's write to the text file. And it did not find the text file. So let's go over here. Did I spell it correctly? No, I didn't. As long as that is a dot. So let's go try it again. Write to the text file. Nothing changed. If I come here to, it says that this file has changed. So we're going to reload it. Yes. And if I come here, you can see that there's now a new value there. Obviously, our date and time are different to theirs, but they did mention that the formats are dependent on the regionals. So they may differ compared to the example that we give. So I'm happy with that. Okay, so there we go. That one's done. Now let's do 3.2.4, which I think is the last question of this OOP paper. The switch will be left on a specific number of hours. If you remember correctly, by the way, over here, we've used that one, we've used that one, we've used that one, and we've used that one and that one. We have not used energy use. So let's make sure that we use it now. The user must enter in the number of hours, which I think we're going to use for our next method. Obtain the number of hours that was entered from the editor box. Call the energy used method. Display a suitable message in the rich editor to indicate the amount of energy used. So we're just simply going to use it and just return its answer. So let's go and try it. So we're clicking on that button. We're getting the value from that edit box. So let's go get the value first. So we're going to use a variable for our hours. Our hours is going to be the value from edt q324.text, but we need to convert that from a string to an int. Then I need to work out the energy, which is going to be a real value. So let's call it energy of type real. And the energy, and we're going to call the object, and we're going to call its energy used function, and we're going to give it the hours that we've just calculated, and it's going to return a real value, and that real value will go into there. So that'll be fine. And then we can simply display in the rich edit. We want to display energy used is with the value and then kilowatts. You'll notice that it's displayed to 1 decimal place. Our first bit of text, followed by the value R energy, followed by a space and kilowatt hour as my next part of the string. But we want to convert this display. It looks like it's 1 decimal place. So just for its sake, I'm going to go float to string F and display that as a fixed value, 8,1, not 2, 1 decimal. So convert that real value to a string, add the word energy used in front and the kilowatt hours afterwards. Let's go test it. So we first do that and instantiate the object. I'm just going to switch it off for now. We know that that works. So let's go and check out what options they gave us. If we get 4 for the 100-watt fan, so we type in 4, there we get 0.4 kilowatts, which is correct. But then for the pool pump of 180 watts, let's change our object to the pool pump. Let's go instantiate this object, and now we're going to use a pool pump for 6 hours. So we change that to 6, we get 5.1, which is the same value we get there. So there we go. I think that's done. Well done. We've done the whole OOP question. Now let's move on to the final one. For more RT exams, click on the playlist tab and subscribe. For more theory help, go to our YouTube channel at Mr. Long Computer Tips. For more general tips, go to at Mr. Long Education on TikTok. And generally, if you don't do it the long way, do it the Mr. Long way.